Hey guys, welcome back to more on our maths. It's me, Dan here, and today we are looking at deriving sine, cos and tan. So, let's start with the first one, sin x. So how would we derive y equals sine x? We can't really use chain rule, product rule, quotient rule because, well, we don't really know what it is yet. So what we do is we use something called differentiation from first principles, which you would have covered in year 12. And differentiation from first principles tells us the derivative equals the limit from h tending to 0 f(x) plus h minus f of x over h. Okay, so what we can do is we can substitute y equals sine x in replace for this f. So what we'll do is we'll quickly rewrite that. So we'll get sine x plus h. But this f is a function, essentially. So it's that. So sine x over h. And remember to include our limit as h tends to 0, which will be important later. So, what do we do from here? So if you cast your mind back to a past topic that you would have done in A-level maths, which is trigonometric functions, trigonometric values, you would know that sine A plus B is equal to sine A cos B plus cos A sine B. But here we didn't use A and B, we used x plus h. So it's essentially the same thing. So we're replacing x with A and h with B, pretty much. So what we'll do is we'll quickly write this expanded form. So that'll be sine x cos h plus cos x sine h. Awesome. And then what we do minus sine x all over h. Okay, so now what? So let's take the common sine x terms and we'll put them together, and then we'll do the same for our cos x term. So what we'll do, we'll say sine x, and then we'll take all the terms involving sine x, so that'll be cos h minus 1, because obviously before this sine x term is a 1, essentially, but we don't really write that in maths. And then what we can do is plus cos x, and then cos x, it only appears once, it's only in one term. And then obviously in the brackets we're going to put sine h. That is still all over h, but what I can do is I can put it here and it here. Okay, awesome. So what do we do now? So if you try this at home, if you get a calculator, now h tends to 0. So if you put a ridiculously small number in for h, so if you put in like 0.00001 for h, then it will give you like a really small number that will tend to the values that I will say in a second. So let's start with this cos h minus 1. So using your calculator, if you do what I just said, put a really small number in for h, that's very close to 0, you'll see that cos h minus 1 over h here will tend to 0. It's going to be ridiculously close to 0. So we're just going to say it tends to 0. Alright? And then over here with the sine h over h, so if you put in a really small value in, it will tend to 1. Awesome. Right, so what can we do then? So we know that this cos h minus 1 over h tends to 0, right? So we can replace that with 0. So sin x times 0. And then we can say plus cos x. And then sin h over h tends to 1. So we can multiply that by 1. Now sin x times 0 would just be 0. So we can get rid of that. And cos x times 1 is just cos x. Therefore, f prime x of sin x is equal to cos. There you go. So that's the first example done. Now we are going to differentiate cos. So the next one is cos x. Alright, so it's a pretty much a similar example. We're sort of doing the same thing. So using first principles, we'll do what we did with the sine one. We'll say cos x plus h minus cos h over, sorry, that should be x, not h, sorry, over h. Awesome. So we need to look at this cos x plus h. Now there is a trigonometric equation here for cos a plus b, similar to the one for sine. So that will be cos a cos b minus sine a sine b. Okay, so what we can do is quickly make that expansion for x and h. So let's do that quickly. So cos x cos h minus sine x sine h. And then on the numerator, we've also got minus cos x all over h. Awesome. So we'll do what we did last time. We'll get a common... So we'll do what we did last time. We'll take all the cos x terms out, and then we'll take all the sin x terms out. Okay, so we'll get cos x. And then looking at cos x, we've got cos h minus 1 over h. And then what we can do is we can minus it, because we've got this minus sign here before the sin x rather than a plus. So it'll be minus sin x, and then what we'll get is just sin h over h. Okay, so we just do what we did last time. We know that cos h minus 1 over h, all of this here, that tends to 0. And we know that sin h over h tends to 1. So what we can do is we can rewrite that. So cos x, and then we'll replace that cos h minus 1 over h with 0, minus sin x, and we can replace sin h over h with 1. And then if we simplify that, well, cos x times 0 is 0, minus sin x times 1 is just minus sin. Therefore, minus sin x is the derivative of cos x. Okay, so for the final one today, y equals tan x. So what can we do? So we don't really need to use differentiation from first principles. As you know, tan x is equal to sine of x over cos x. Now, for those of you that watched my last video, I went over the quotient rule, and we're essentially just doing that, okay? So we can set u equal to sine x, v equal to cos x, and we know du by dx would give us cos x, and then dv by dx would give us minus sine x, and then what we do is the quotient rule from there. So the quotient rule is this, what I'm about to write down. So hopefully you remember this, and we're just going to substitute all of our values into the quotient rule. Okay, so v is cos x, u prime is cos x as well, so we can say it's cos squared x, minus u, u is sine x, v prime is also sine x, so we can say sine squared x. There should be a minus here, because obviously it's minus sine x times sine x, so it'd be minus sine squared x, okay? And then over v squared, v is equal to cos x, so that'd be cos squared x. Okay, so as we can see in the numerator, we've got a double negative. So two negatives make a positive. So we can say cos squared x plus sine squared x over cos squared x. Okay, so there is another rule that we need to know. So sine squared x plus cos squared x is equal to 1. Alright? So therefore, we can replace the numerator with 1. Okay? And that will be over cos squared x. And another way of writing 1 over cos squared x is sec squared x. Therefore, we have our derivative of tan x, which is sec squared. Okay, and that is it. So hopefully you've enjoyed this video. A bit of a shorter one today, but if you do, please like the video and subscribe. Peace out.